Welcome to Advanced Data Analysis 2 with me, Erik Erhardt, Professor of Statistics at the University of New Mexico. In this video, I hope to get you started with Class 8, a continuation of Randomized Complete Block Designs, where I give you a lot more to do by yourself. So we'll scroll down to Class 8, and it's got a markdown file and a data file, so I will save both of those to my data analysis folder. And we'll go over to RStudio, open the markdown file, let me go get the path. Set the working directory to the current file and knit it. We'll open it in the browser and we'll read through it. All right, so a fast food franchise is test marketing 3 new menu items. To find out if they have the same popularity, 6 of the franchise restaurants are randomly chosen for participation in the study. Okay, so we've got 3 menu items and we've got 6 restaurants. In accordance with the randomized block design, each restaurant will test marketing all 3 menu items. Furthermore, a restaurant will test market only 1 menu item per week, and it takes 3 weeks to test all the menu items. The testing order of the menu items for each restaurant is randomly assigned as well. This is really important that menu item 1 isn't always the first one, followed by menu item 2, menu item 3. You want to break that up. Basically, control what you can, randomize the rest. So we're controlling which restaurants, we're controlling the menu items, but the order, we can't really control the effects of order, so we need to randomize it. The table that we're going to see below represents the sales figures of the 3 new menu items at the restaurant after a week of test marketing. Okay, so here is the what I'd like you to do. We want to run a randomized complete block design analysis. So first we need to read in, reshape, and plot the data and describe the relationships that we see of the sales response versus which item it is and which restaurants they were tested in. We're going to fit the two-way Anova model for the randomized complete block design. We're going to assess the model assumptions. We may need to do a transformation if these assumptions are not met. We're going to perform the Anova test of stating and interpreting the hypothesis for difference in the item mean sales. Okay. If we reject that null hypothesis in favor of the alternative that there are differences in sales, then it will be appropriate to perform the pairwise comparisons using the Tukey on a significant difference correction and interpret those results about which items are different than the others. And finally, let's make a recommendation as though we are a statistical consultant and answering the question, which of these sale items should we be selling? Obviously the one with the most, right? Which one's going to make you money? All right, so here's the data. We're going to elaborate the tidyverse and read in the ADA functions for the residual plots. Wait a second. This is the data right here. Do I also have the data in another table? Or did I make a mistake? I don't know. But anyway, I think I think this is the data, and we don't need that DAT file that we downloaded. All right, so there's the data. It's just a rectangle. So we need to do everything else. So it looks like I get you started with reshaping and plotting the data. I have reshaped it using pivot longer to go into long format. So we have the 6 restaurants, A through F. We have the 3 items, item 1, 2, and item 3. and then we have the sales in some units. Maybe that's the number that were sold or the dollar amount. If I page up for a moment, we don't really know what the units are for those. Okay, I've also calculated the mean. So it looks on the surface that item 3 is best and item 2 is the worst. And we're going to be looking for statistical evidence of that observation as well. If you group by restaurants, it seems that there are differences in restaurants as well. Restaurant D, or even less than that, is restaurant A had 27, whereas restaurant E had 41. Okay, and then I give you, that's the bottom, then I give you everything else to do. So where are you going to get the code for all this? Assignment 7. Okay, so let's start working through this together. So I'll go over to RStudio. I'm also going to open up the assignment 7. And I'm going to start by just going between the two documents, assignment 8, which where we're working now, and assignment 7, and just copying the code from 7 over to 8 that we need, and then we'll modify the variable names and dataset names to make everything work. All right, so I'm just scrolling down through the data down to fitting the model. Oh, in fact, we don't even have the plot of the model, plot of the data yet. So let's do that first. So I'll go over to class 7 and scroll down for the plotting code. Now recall last time within the video I added a geom text for the observation numbers, and that required this ID number. I will leave it to you whether or not you want to have that in there or not. I think we can probably, I don't know, it's pretty easy to add the ID number, so maybe we will do it. So I'm just pasting the code in here for the plot, and I'm going to go up and do that ID number. Here's the data set, food long, and here's the, oh, I already have a mutate, so I can do it right in here. We're going to create a new variable, ID equals 1 to n. Okay, so now we have an ID number if we run this. All right, so it's sort of a matter of taste whether you want to copy each piece of code over and then like copy all the code over first and then work through and modify each piece, or whether we do one at a time. Why don't we just do one at a time? It may, I don't know. Actually, probably I go back and forth. All right, so here's the dataset name. You know what? I think it may be easier to move all the code over, and then we can do find and replace and fix all of it at once. Let's do that. Okay, so fit the model. So here's the fit model code. Okay, paste that there. Assess the model assumptions. I'm going to grab that code there. Now I'm switching back and forth between these tabs using keystrokes. I don't know if you know this, but these are things I use all the time. If you hold the Alt key down on a Mac, you'd hold the Command key down and press the Tab key and continue to hold the Alt or Command key down. It will let you switch. I'm just pressing the Tab key. It will let you switch between programs that are currently running. Okay. Similarly, on a Windows computer, if you press the Control key and press Tab, it will help you. You can switch between windows. And you'll see on the Tab key, you've got arrows pointing to the right and to the left. So if you do Control Shift, a Shift key does the higher symbol on a keystroke. The lower symbol on the Tab key goes to the right. So If I'm over here and I press Control Tab, it's going to go over to this tab, over to this window. But if I do Control Shift and then press Tab, it's going to go to the left. So you can switch between windows using those keystrokes. On a Mac, you probably can do something similar. I think the Macintosh keyboard is awful, so I'm not going to try too hard for that. Okay, so anyway, so there's this assess model assumptions. We can put a place for your solution if you want. It doesn't matter too much. I would just type below there. Okay, state and interpret the hypothesis test. Okay, so that is the Anova. Good. And then we've got, okay, now we can scroll down through this because class 7 had a few different models to fit. Finally, here is the EM means code, which will do the pairwise comparisons. Okay, so if appropriate, do the pairwise comparisons. And then what is your recommendation? There's no code for that. But I do want this plot here. In fact, I'm going to copy and paste this interpretation code to, or this text. Whenever I create this plot, I include this text because I often need to explain this plot to collaborators, and that piece of text does that. Okay, and yeah, so let's do a summary as well. I might as well copy this text as well. Okay, so I'm just copying all that text over, and that's it. Okay, and then make a recommendation. Good, so we've got all the code over here. Now we just need to do a bunch of find and replace to fix things. So the data set that we're using is DAT food long. I'm highlighting that and I'm pressing Control C to copy it. And D2 all is the data set that was used in class 7, but I want that data set to actually be DAT food long. So now I'm going to press Control F. You can also do find and do the find. Here it is, Control F, find. The thing that I highlighted goes automatically into the find box, and I'm going to replace that with paste, DAT food long. This one's already highlighted, so if I press replace, DAT food long will replace this text. There we go. And it moved on to the next. So I'm just going to replace all these data sets throughout the code. Okay, it did all of them. Now I remember that I also had some code from example 3 in class 3. So let me just see if there's one of those. There isn't. Okay, so I think I replaced all the data sets correctly. Now we have some other variables. Let me scroll up again. We have the y variable is where. Okay, so that's the response variable. In our current data set, it's sales. So I'm going to replace where, Control F, watch up here. When I press Control F, where is going to pop up here. Boom. Okay, and then I'm going to replace that with paste sales. This one's highlighted, so I'll click replace. Sales, sales, sales. Okay, so tire sales. We'll need to modify the title of the plot. Okay, very good. Now the brand of tires from class 7 was the main variable, but now it is the items. Okay, so item is the main X variable, whereas before it was brand. So I'm going to highlight that, Control F, so find and replace again, brand with item, replace, 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 replace. Okay, and then we do have one other variable, which is the restaurant. And I probably should have put in the design 3 code here, but I think I can probably do it from, you know what, because I don't encourage you to do things from memory, I'm going to follow my own advice. I'm going to go over and get the plot code for example 3. Basically, I just need this one line here, the geom line. I want to do a geom line for each restaurant. Okay, so I'm pasting that in here, and these are not, oh yeah, we've got car. Okay, so let's replace search by car, and that is now restaurants. Oops. Let me make sure I spelt the variable name correctly. Restaurant. Okay, so we'll find the next one. There it is. It's actually highlighted the second one. So if I start here and go all the way through the document, it will start again at the top and it will find this one. So I can replace. Oops. That's okay. Restaurant. Replace. So the car package, we do not want that one. In fact, I could have avoided that by doing match case. We only want car with capital C. So let's do next. We do want to replace this one. Okay. Okay, I think I have everything. And of course, if I don't, I'll get an error and we can deal with it. So let me run this. I think these observation numbers are a bit cluttery. Maybe I'll make the size smaller. Size equal a half. Nope, that's too small. Okay, well, let's not worry too much about those labels. Or you can make it very dim. Alpha equal 0.2 has a very low opacity. And now those labels are there. You can see them if you look for them, but they don't really stand out. I think that's pretty good. Okay, it looks like it's good to control for restaurants. Like restaurant E, these blue boxes with the X's are up high. And some of the other restaurants are just sort of are low and stay low. Okay, so I think that's probably good to control for restaurant. I think this is a pretty good plot. We do want to modify the title. So this is sales by item and restaurant. And the sales are not in mil. I don't know what the sales are in. The only reason really to have this label for the y variable is if you had something different than the variable name. The variable name is already sales, so I'm going to remove that label. Let's run this plot code again. That will fix the title. Looks pretty good. Okay, that's a great start. Okay, we're going to fit the model. Now we've got item, as sales is the response variable. We've got by item, and we need to add here restaurant. That would have already been in there if we had used the fit for the third example from class 7. Now what do we want to call our fitted object? It doesn't really matter too much. But fit D2 doesn't necessarily make sense because it's from something else. We can do like fit sales, or I think what I do sometimes is S is the sales variable, IT is the item in restaurant, S it. It looks like I'm like it's a little bit of, anyway. Okay, there we go. So fit the linear model, control enter, and we'll look at the diagnostic plots. Now this is going to start to get a little bit small in this little window. I can use this left arrow or Control Alt F11 to scroll back to previous plots. Okay, here's the beginning. If I go back one more, it's the Anova style plot somewhere. Okay, So residuals in terms of normality for the QQ plot look pretty good. Observation 12 is a little more influential. Does this quite look right? How many observations do we have? 15, 16, 17, 18. Yeah, we have 3 items, 6 restaurants, that's 18. Okay. Good. They all have the same leverage. That's not important. So observation 12 is a bit large. Let's go see why. Observation 12 is this value up here. It's from the green restaurant C. I think it's an outlier because actually it's these blue crosses D. So there's a blue cross down low, and then it's suddenly the highest one. So it's strange for this restaurant, right? This restaurant tends to have low sales for item 1, low sales for item 2, but the highest sales for item 3. So it's that strange behavior that makes that an influential observation. Okay, so we sort of understand it. We don't have a way to explain it. Maybe someone who works there bought a whole bunch on their breaks every day. Okay, these residuals look good. Equal variance. Each of these only has 6 data points. This one does look like it probably has a bit less variance than the others, but we do have an outlier out here. So it's just a matter of whether you drew the whisker down to that point or not. So I think these look not too bad. These probably look not too bad. Each of these box plots only have 3 data points in them. So what the points that are being plotted are the tips of the whiskers, the top value and the bottom value, as well as the median. And then the ends of the boxes are just being interpolated to be the midpoint between the tip and the median. Anyway, 3 observations. You can't really say much about equal variance. That's about as good as it gets for Box Cox saying we've got normal residuals. Observation 12 is sort of consistently an outlier, but it's also in the middle of the plot for most of them, except for this one. So it seems to not really be influencing the slope variable. Except here, perhaps 12 is here in the corner. It would be pulling this one up, but on the other hand, here's 3 also pulling it down. Yeah. So if observations 12 and 3 weren't there, you'd have a very negative relationship here. I don't know. We don't have a lot of evidence for problems in here, so I feel pretty good about these results. The normality test seems that it is consistent with normal residuals. Okay, so go ahead and write out under here whether the model assumptions seem to be met or not. Okay, so if oh yeah, so I guess we didn't look at the let's do the hypothesis test now. Boop. So we fit the ANOVA, and we've got items. We do have evidence of differences between items. For restaurants, now each restaurant only has 3 observations, and we have 6 restaurants. So we don't have even if there were differences, like true differences between the restaurants, which it seems like there is based on the plots, we just don't have enough data to conclude that way. So we don't have evidence that there are differences in restaurants. So at this point, can we remove, like model selection, can we remove restaurants from our model? No. It was a part of our statistical design to include restaurants and to randomize each item into each restaurant. So we should include restaurants in the design or in the analysis of the of the data, regardless of whether restaurants are significant or not. Okay, but anyway, here, good. We've got some differences between items. So you write out that conclusion here, state what the hypothesis is. The Anova hypothesis is that the mean sales for each item is equal. The alternative is that the means are not equal, and draw your conclusion. Let's take a look at the results now. So we fit the linear model object. It was called fit SIT, and we just want to put that in here in this EM means. We want to replace the fitted object name to be the correct one. Okay, and we can run this code for the pairwise comparisons. Those results, this top one is just the estimate and the confidence limits for each item, and then this bottom one are the actual pairwise comparisons, which are adjusted using Tukey. And we've got between item 1 and 2, no difference. Between item 1 and 3, no difference. But items 2 and 3, there are differences. Let's see. So those are the two with the most extreme means. Observe, item 2 has the lowest mean of 25. Item 3 has the highest of 39. And we see, in fact, that difference of 13 is significant. One more thing to comment here. We've got a negative 13. That's because we've taken item 2, the item 2 estimate of 25, minus the item 3 estimate of 39. And so the larger number has the minus sign, so the result is a negative estimate. All right, let's look at a plot for this. Oh, you know what? I don't know. This doesn't really matter too much. Let's rename this, I guess. So the contrasts between between items. How about that? I'll just rename that object. And I'll need to go and rerun this code because I've now renamed the object. So run that again, go down to the plotting code, run this. Very nice. Okay, so item 1 is at the bottom, item 2, item 3. We look at the means across the horizontal axis, drawing vertical lines. The items 2 and item 1, the red arrows are connected by a vertical line there. Good. Item 3 and item 1 are connected by a vertical line here, so they are not different. But items 2 and item 3, the red lines, do not overlap. So those two are statistically different. That's a visual representation of the table that we just saw, here. Items 2 and 3 are different. Very good. Okay, so that's the summary for this, and then we've got this plot here. Here, I can help you do this one. So we've got the means. Actually, I should have helped you do this for class 7, but I skipped over it. All right, so order this by mean. So what I would do here is I would do item 2 has the lowest mean, then item 1, and then item 3. And I would even add to this, I'd put the means below, 25.8. 33.7, 39.2. Okay, and now which pairs are different or not different? So, right, you want these lines to connect items that are not different. So items 2 and 1, as we saw over here in the plot, items 2 and 1 are not different, so they should be connected by a line. And items 1 and 3 are not different, so they should be connected by a line. But items 2 and 3 are different, and there's no line that are connecting both items 2 and 3. So that's a nice way of summarizing there. All right, so what's our recommendation? Well, looks like, so item 3 brings the most sales. I don't know what the units are, either numbers sold or dollars. And item 2, the least sales. Okay, so I would say sell item 3 when you can, but item 1 is also a good choice since not significantly different from item 3. Something like that would be good. All right, let's make sure that this compiles. We've made a lot of changes, but we have run all the code in order, so I don't believe that there should be any problem with this running. Go look at it in the browser, and we'll just sort of scroll through quickly. I didn't type all the answers, as you know. Whoops, I pressed the tab key by accident. Okay, so there's the data. We reshaped it, and we pasted in this plot. And I'll zoom out just a little bit. Plot looks good. I like the numbers in there that are very light. So there's a lot in this plot. You can so basically the assignment's over. I'm going to say a few more things about this plot, and then I'll probably stop the video. So this plot is a little bit too busy, I would say. Maybe it is worth removing those lines. I don't know. At first I was thinking, should we facet it by restaurants, but that doesn't really work because we need these grand means on this plot. So I would make a decision here if this was my my project to, and I was like presenting this to collaborators and we were going to publish something about this. How much do you really need on this plot? I really do like the individual restaurants and the individual colors and the lines. One thing that makes this plot a little bit noisy is the horizontal spacing of the symbols. So I might just choose to align all of those on top. The other thing is that I think I'm currently plotting the red diamonds on top, and that's purposeful, that I want the summary to be the thing that is sort of in the most foreground. But you can see these red diamonds even if these smaller symbols are plotted on top. So I might switch the order. So if I go back over here, so I'm just going to monkey with the plots for a minute to make some improvements. So find the plot code. So I'm going to put the summary. So we've got the diamonds and the confidence limits. In fact, I want to put the confidence limits first so that the diamond is printed on top of the confidence limits. Let's put those early on. So we've got the horizontal line, which is the grand mean. That's still good. The geom text, I think, should go on the back. And then put in the means and their confidence intervals, and then plot the lines, but don't jitter them. Make the width equal 0. And we could, and then the lines could even be a little less, dark. And let's try that. And I'm going to knit it because it looks a bit different in this little plot window than it does in the HTML file. If it was me, I would just be looking at it in this window, but I think it is easier for you if we look at it here. This is a bit tidier. Just changing the horizontal positions of these symbols made a big difference. Now, once you stop jittering, the numbers, the observation numbers, are right on top of where the symbols are. So it makes them really hard to read. If you wanted to make sure that you could read them, you could choose to offset the labels of the points to the left or to the right, or just choose not to plot it. Because it might be something that you'd be interested in at some point, let me look for the help for the geom text, and because I believe that there is an alignment, there's a nudge X and a nudge Y. Okay, so we could nudge those labels. Let's just look at, so I'm scrolling now down through the arguments to get a description of the nudge variables. Horizontal and vertical adjustments to nudge labels by, useful for offsetting text from the points, particularly on discrete scales. Okay, so let's see if there's an example of this. I'm sure that the nudging, is probably centered at 0 and takes positive values, maybe -1 and +1. Okay, so I'm having trouble finding nudge in here, but if I just type it in this search box up here to search within this text, I'm going to go to the next one, see if there's an example. Okay, here's an example, nudge, okay, 0.5 and 0.05. So let's just try this. Geom text alpha, okay, so then we'll do nudge. Let's do horizontally, X, and we'll do, how about we do 0.5. We'll see what happens. Okay, so this is the type of experimenting that I think is good to put into this plot window, because I might do small adjustments, a few of them, and when I'm happy I'll run the whole thing. Okay, you can see, so you can see where the numbers are, I hope. I nudged them 0.5 and they went all the way over here. That's because the distance from item 1 to item 2 is 1 full unit. Okay, so now I have a sense of scale. Probably this is sufficient if it's like 0.1. Let's run this code. Okay, so now the numbers are right next to it. That's a bit better. So if I really wanted those labels in there, I think that's about where I would put them. You could also do a -0.1, and that should put it on the other side, on the left side. There we go. So either of those strategies I think works very nicely for labels. Okay, I think that's the end of this one. I'll see you in the next one.